With the lower mount block now attached, I'm putting the base on. I'm gluing the pieces of the base to each other, but I'm not gluing them to the frame legs. With the friction and a little bit of squeeze out, it's pretty securely held, I think. Nonetheless, I will put some screws in, 4 of them. I just think at some point I may want to remove this, and the ability to take those screws out and perhaps be able to knock this back off again seems like a good thing. Here's a trap for the unwary. Measure up your motor first. It turns out that my motor, a 1 horsepower induction motor, is quite a bit bigger in dimension than the one in Matthias's plans. So on this shelf here at the back of the frame, where the motor is supposed to sit, I'm going to have to put an extension. You may be thinking to yourself, gosh, those are fine teeth, but it's not actually a bandsaw blade. It's what we used to call brick strap in the locksmithing business. It's a really excellent kind of steel to make certain picks and decoders out of. Mostly these days when you get a packing crate with strapping, or indeed a pile of bricks with strapping, the strapping is plastic. But this is from about 15 years ago, when a rather hefty piece of metalworking machinery arrived in a packing crate with genuine brick strap around it. And I wanted to check that the suggested 105 inches is correct, which it seems to be, and I wanted to do some preliminary testing of the tracking and alignment, and that's not looking too bad. So now I'm off to order the actual bandsaw blades. Well, I've reached a very satisfying milestone moment. There's enough bits on here now to give it its first trial spin up. The tyres are on, the shafts are true and fixed in place. I've decided to use Jubilee clips to do that. With a hollow shaft you can't tap the end and put a screw and washer in to hold everything from falling off, so Jubilee clips it is. They're also serving the function of holding the shims in place. I've put a spacer, let's go around here, I've put a spacer behind the motor, guessing where it ought to be to get the right tension on the pulley belt. I remember from older cars advice of about 1 inch play on the longest run, which is what I've tried to do. So I popped that spacer in there, pushing the motor to where I think it's going to be fixed, and I popped some clips on the back to give it some stability. There's the tension crank and the tilt mechanism, so let's give it a go. Well, it's not too noisy, and it's not vibrating too much. I might run it without the pulley belt to see if that indicates which wheel has the more wobble. And it seems to be tracking nicely. As with most people who try this, once the tension is on, this shaft here does tend to cant upwards, so I've used my Battenberg mount block here to counter that by tightening these 2 bolts here and the hardwood pushing the shaft into the softwood. As the tension goes on to the shaft, it doesn't deflect as much, and I can get about ½ degree adjustment by doing that, and that, thankfully, seems to be enough. I'm just working on the lower rear enclosure around the belt here, and it really is ridiculously fiddly. It's because of the dimensional differences between this and the plans. These 19mm laminations in the main frame and this larger motor have made a bit of a difference. I don't think you need a 1 horsepower motor. If I remember correctly, 3/4 of a horsepower is adequate for this size of bandsaw. Here's the main thing I'm keen to get on, which is a brace that's going to stop this thing falling over. Before I had the motor on there was quite a tendency to topple with the weight of the wheels. Once the motor was on there, that helped a bit stabilize it, and when this piece is on, that'll give quite a nice big leg out here. The top blade guide is mounted at the bottom of a guide bar, and you need a notch cut in the corner of the top part of the C-frame, and the suggestion from Matthias is that you hog this out with successive cuts from a circular saw. Well, I don't know if it's my technique or my circular saw, that certainly left quite a mess, and I finished it off instead with a plunge router. And if that hole is now too deep, and I don't think it is, I can just widen the bar a millimetre or two, I can put a shim here of some nice smooth wood. As you probably know, the lower blade guide blocks are mounted at the bottom of an arm that goes up and down, or bar as it's called in the plans, and that bar is pushed into that notch on this bevel here. So we need a clamp. I need to bevel that bit there, because I haven't got a bandsaw, of course, and I can't take a big thick block of wood and bandsaw a shape into that. So rather than cut a triangular section and try and glue it on there, which would be very difficult to clamp, I've glued a regular section on there and I'm going to bevel it on the table saw. Now the plans call for a shallow bevel here of 35 degrees. And I wouldn't be able to cut the corresponding angle safely into that on the table saw. So I have made this 45 degrees and I will be able to cut the corresponding bevel on the table saw. I've left this clamp oversized because, as usual, you have to take account of the lamination size, changing the dimensions. The other part that's needed is a shallow rebate to go down the end here, which holds this away from the end there. You don't want it right on the end, you want it off the end there and pushing equally in that direction and that direction on this guide bar here. So now I need to make a little rebate to go around the corner to act as a hook over here and to hold this main part off the end of the frame member. Those dimensions seem fine, so now I can trim off these excesses. And now, with only a few more bits added, I ought to be able to make a star knob for this on the bandsaw.